Hello friends, welcome to my YouTube channel Reasons and Logics. So friends, on this YouTube channel I would be posting my lectures regarding the syllabus of year 11 and year 12 physics, and what else I would be adding, that I would be mentioning side by side. So initially I'm starting with the syllabus of year 11. So the first chapter that I'm going to explain is units and measurements, and the book on which mainly I would be concentrating will be SL Arora and NCERT books. Any other book or any other content which I'll feel like adding, I'll be telling you side by side. Without any further delay, let's get started with the topic, that is units and measurements. So friends, first of all, without entering into main content of any chapter, we need to know about some basic definitions. So is the case with this chapter. So firstly, we would be writing few definitions which are very important, and guys, this chapter is really very important if you want to study physics in detail, because in this chapter you'll get to know how to measure any quantity, how to write dimensional formula of any unit, what are the units, how to measure, why to measure the quantity. All those things we would be covering in this chapter, and this chapter is really important. So let's get started. So the first definition is, what do you mean by a physical quantity? Physical quantity, the definition of physical quantity. So all those quantities which can be measured directly or indirectly, or we can say that these are the quantities in terms of which physical laws of physics, you can write, in terms of which laws of physics can be explained. Fine. So these are the quantities which we measure to define any law of physics. So those quantities are known as the physical quantities. Example, you can get to understand it better with the examples. So examples are length, mass, electric current, etc. So these are the quantities which we use to define any law of physics, maybe Newton's law or any other law. All the laws are explained on the basis of these physical quantities. Now, these physical quantities are basically of two types. Number one is fundamental, and okay, let me write here only. Number two is derived physical quantities. Fine. Next, we need to know what do we mean by fundamental physical quantity and derived physical quantity. So we have physical quantities, okay? So we have physical quantities of two types. Here we have fundamental, and here we have derived. Fine. So fundamental physical quantities are those which can be considered as independent of all other physical quantities. Just write down the definition. I'll be explaining it in a better way with example. And they cannot be defined, and they cannot be defined on the basis of other physical quantities. Fine. Now, basically there are 7 fundamental quantities. Fine. What are those? I'll tell you. Firstly, we'll define what are derived physical quantities. All the physical quantities except these 7 fundamental quantities are known as derived physical quantities. Fine. And to define this, we write derived physical quantities are those whose defining operations are based on other physical quantities. Fine. Okay. So now we'll see what is the basic difference between fundamental and derived physical quantities with the help of their examples. Fine. I mentioned that there are 7 fundamental quantities. Fine. Now I'll be writing those 7. Mass, length, time, electric current, temperature, luminous intensity, and number 7 is amount of the substance. Fine. So this simply means that we cannot use any physical quantity in the world to define mass except the mass itself. Mass is defined by itself only. Length is defined by itself only. It cannot be derived from other physical quantities. Now see, I'll write few examples of derived physical quantities. Derived ones. Fine. So their example is, say, momentum, force, acceleration, etc. etc. There are many. Now I'll explain what is the basic difference between the two. We can define all these physical quantities in terms of these 7, any of these 7. Now see, what is momentum? It is represented by P, and it is equal to mass into velocity. Fine. Now mass is a fundamental quantity. What about velocity? We all know that velocity is nothing but distance upon time. And what is distance? Distance is nothing but a certain length. So length upon time. So length upon time. So momentum becomes mass into length upon time. Have a look on all these 3 quantities here. We have mass, we have length, we have time. So momentum we have defined in terms of 3 of the 7 fundamental quantities. So next thing is how to make measurement from a physical quantity. Fine. What is the basic formula with which we can make a measurement? Generalized formula, otherwise we use different formulae for different physical quantities, but general measurement of a physical quantity can be done by the multiplication of two things, that is numerical value multiplied by size of the unit. So, when we have to measure any physical quantity, these are the two things which we require. Number one is numerical value. Number two is size of the unit. For example, we want to know a mass of a particular thing. Say a mass of a big ball. Mass of a ball. Fine. Now we require what is the numerical value of the mass and what is the unit in which we are measuring that mass. Suppose the mass of the ball is 5 kg. So this is numerical value and this is the unit. Fine. Now this same mass can be represented as 5000 grams. This is also the numerical value and this is the size of the unit. Now this difference tells us about the size of the unit. Fine. Now see, what can we infer from here? We can very easily say that any numerical value is inversely proportional to size of the unit. Very easily you can see here. Lesser the numerical value, bigger is the unit. Larger the numerical value, smaller is the unit. So clearly our numerical value is inversely proportional to the size of the unit. Fine. So to measure any physical quantity, we require numerical value and size of the unit, and this numerical value is inversely proportional to the size of unit. This is very clear. Fine. Now next. Now we have been using the word unit. What do we mean by this word? What is a physical unit and why do we require it? Fine. So the next definition is physical unit. Fine. So firstly write its definition, then I'll be explaining what does it mean. It says that the standard amount of physical quantity chosen to measure the physical quantity of same kind is called physical unit. Fine. Now we have, so basically what does it mean? It means that to measure any quantity we require a reference regarding with the help of which we can define any quantity. So we have 7 fundamental quantities. For all those 7 fundamental quantities we have chosen a standard, like with reference to which we can measure all the physical quantities. For example, we know that mass is a fundamental quantity and it has, I'll be writing the standard units of every fundamental quantity, but mass has say kg as the standard. We have chosen standard unit as kg as the standard unit. Fine. So if any of the thing has the mass 1000 gram, we can measure with reference to this. Like 1000 gram means 1 kg. So this is the standard or referral to which we can measure any physical quantity. Fine. By making reference to this, we can measure any physical quantity in terms of this standard unit. Fine. Okay, so now after making yourself very much clear about how to measure a physical quantity, the very important thing that we are going to study next is what do we mean by a physical unit. We were saying the size of the unit and everything. Then what do we mean by a physical unit? So our next definition is, what do we mean by a physical unit? Fine. So firstly we'll write its definition and then obviously I'll explain it. It says that the standard amount of physical quantity chosen to measure the physical quantity of same kind. Physical quantity of same kind is known as your physical unit. For example, if any system, we have different systems in which we choose different standards. Taking those standards as the reference, we measure all other physical quantities. See, you'll get to know what I'm trying to say. So the first one is, say in any system we have mass is the fundamental unit. So we have kg as its standard. Fine. So what we try is, whenever we are talking about the system in which we have chosen kg as the standard, we'll try to convert all the mass quantities into kg. For example, if we have any quantity, say it is 5000 grams. Then if we are doing lab measurements, we will not mention our answer in grams. If we are talking about the system in which kg is the standard, then we have to write it as mass of that quantity is 5 kg, because 1 kg is equal to 1000 grams. Fine. So this is the thing. So it is very important to choose any standard so that we can compile each and every quantity in terms of that standard. So this is what this physical unit means. A standard referral is basically known as a physical unit. Now we'll be studying about various systems in which we choose different standards of these fundamental quantities, and what is the system that we are using at present for all the lab measurements and all the measurements that we have to do precisely. So now we'll be studying about different measuring systems. So let's start with a system of units. Firstly, we'll define what do we mean by the system of units. It is nothing but a complete set of units which is used to measure all kinds of fundamental and derived units, derived quantities, sorry. Fine. So basically it consists of a set of units which will give us the units to measure the physical quantities, and those physical quantities could be either fundamental or derived. Fine. Now we have different systems in which we choose different standards and we measure our fundamental quantities according to those standards. So I'll try and make a table so that you people can easily sort out what I mean. Let me draw it first. Firstly, I'll write three systems. Number one is, say, CGS system. Number two is write FPS, and for number three write MKS. After this I'll come to SI. Fine. Here you can write like origin of the system, and then you can write standards. Fine. What are the standards for different quantities in these particular systems? Fine. Okay. So let's see. Okay. So both CGS and MKS are French-based systems. So these were originated from France. French-based system. This is also a French-based system. FPS is a British-based system. Now all these three systems give us the standards for length, mass and time. Fine. Standards for, always they give the standards for only 3 quantities out of 7. So number 1 is length. Let me write it here only so that we can just add to it afterwards. Standards. So here we have length, mass, time. See, CGS. C means centimeters. So according to this system, centimeter is chosen as the standard for length. For mass, grams is chosen as the standard for mass, and for time it is the seconds, or simply S. Fine. For FPS system, for length it is foot, for mass it is pounds, and for time it is again seconds. For MKS, length is measured in meters, and then mass is measured in kg, and then time is measured in seconds. So these were the standards given by CGS, FPS and MKS for length, mass and time. Now comes a system which is used internationally, and today we follow that system, and that system is known as International System of Units, or we say SI units or SI system of units, which is also French based, and that system provides us standard for each of the 7 fundamental quantities. Okay, and rather 7 fundamental quantities and 2 supplementary quantities. So now we'll proceed forward to SI units in detail. So SI units, or it is also known as, in France it is somewhat called like Système Internationale, but right now we know it as the International System of Units according to its Indian version. Now firstly I'll write the 7 quantities, and then I'll write the standards provided by the system for all those quantities, and then we'll write the 2 supplementary quantities. Okay, so number 1 is length. Number 2 is mass. Number 3 was time. Number 4, temperature. Number 5, luminous intensity. Number 6 is, I think I missed some quantity. It is electric current. Firstly, it is electric current. 5th is electric current. 6th is luminous intensity. And 7th is amount of substance. Now let's write what are the standards that has. Now let us write what are the standards chosen for these quantities. Okay, so for length it is meters. that we write it as m. For mass it is kilograms, that we write it as kg. For time it is seconds, that we write it as s. For temperature it is Kelvin, that is written as K, it is Kelvin. For electric current, amperes, or represented as A. Luminous intensity, candela, or CD. Amount of substance, mole, and represented as MOL. Fine. So whenever we would be defining any law of physics, we would be defining it in terms of these 7 physical quantities, and units that we would be choosing or using would be these 7 units, and these are its representations. Only these representations are going to be used for further calculations. Fine. Now these are the fundamental quantities. Fine. Now what about the angles? So this system gives us the units for 2 angle measurements also, and those measurements are known as supplementary units, or those are known as supplementary units. So what are the supplementary units? Number 1 is for plane angle, and number 2 is for solid angle. This is the angle measurement for 3D, and this is a simple your plane angle that you measure 30-40 degree. Okay, so this angle is measured in terms of radians, and it is represented as RAD. Solid angle is measured in terms of steradians, and it is represented as SR. Fine. So this was all about your system of units. Which is the system that is used presently? Why is it used? Because it obviously gives you the fundamental units for each of the fundamental quantity, right? So we use SI units because it gives the particular standard for all the 7 fundamental quantities and 2 supplementary quantities. Fine. Now we need to define each and every fundamental quantity. So next we are going to study about advantages of SI units over all other system of units. Why SI system is chosen as the international system of units. What are its advantages? Fine. Okay, so advantages. Number 1 is that this system of units is a coherent system of units. Fine. What do we mean by coherent system of units? This coherent system of units means that we can derive any of the physical quantity by simply multiplying and dividing those 7 fundamental quantities. By simply multiplying or dividing 7 fundamental quantities, we can define any of the quantity which is not fundamental. Fine. Number 2 is, this is a rational form of system, rational kind of system. Fine. Now what does this mean? This simply means that, like in MKS, what happens is that in this system, mechanical energy is defined in, say, joules. Fine. Heat energy in calorie. So different kind of energies are defined in terms of different units, but in SI system of units, all kinds of energies are measured in terms of joule only. Fine. So this is one important thing which SI system has, and other systems do not have that. Okay, so Number third, SI system is metric system. What does this mean? This simply means that when we have to convert any quantity which is not in the standard unit, we have to convert it into standard unit, and we can convert it simply by multiplying or dividing it by powers of 10. For example, we have any quantity which has a measure of say 5000 grams. Fine. Now we have to convert it into kg because we are measuring the things in SI system of units. We know that 1 kg is equal to 1000 grams. That is 10 raised to power 3 gram. Fine. So simply this is your 1 kg. Fine. So we can write it, we can use the unitary system. 10 raised to power 3 gram is equal to 1 kg. 5000 gram will be equal to 1 kg into 5000 gram divided by 10 raised to power 3 gram. On solving it, this 10 raised to power 3 is nothing but 1000, so this will get cancelled with this and gram will get cancelled with gram, and we can write it as 5 kg. Fine. So this is the thing which I was trying to explain. This is what we mean by a metric system. Fine. Next very basic advantage is that it is internationally accepted system of units. Okay, so this was all. These were the advantages of SI units. Next we are going to learn about what are the basic rules of writing the units under SI system of units. Fine. Okay, so let's write the rules first. So next is rules to write symbols under SI system of units. Whenever we are writing a symbol, we have to write it in small letters. For example, kg. Both K and G are small. Okay? And we are not supposed to write it as like kg full stop. No. These symbols are never ever followed by full stop. Never followed by full stop. Fine. If the symbol is after the name of scientist, if our symbol is after the name of scientist, then the initial letter is capital. Fine. For example, Kelvin, K is capital. It is after the name of scientist. So Kelvin, for Kelvin, K is capital, but whenever we are supposed to write the full name, like when we are supposed to write Kelvin full word, even though it is after the name of scientist, we are supposed to write it with the small alphabets only. Fine. And the last rule is whenever we are writing a symbol, they are never written in plural form. Fine. Never written in plural form. For example, if it is not 1 kg, it is say 10 kg, we are not supposed to write it as 10 kgs. No. It simply means kg multiplied by second. So this is completely wrong. So these are the 5 rules that are followed while writing the symbols or names of the units that are chosen as standards for 7 fundamental units. Fine. So friends, I think this was all about this video. Rest of the explanations and rest of the topics I would be covering in my next video. So see you all in my next video. Till then, take care, bye-bye. And don't forget to like this video, share this video, do subscribe my YouTube channel and press the bell icon for all the latest updates. And you can also follow me on Instagram. I will be mentioning my ID and link in the description box. Thank you.